Okay, this is my week 5 wrap up. So for week 5, you only had a knowledge check. You didn't have a discussion post. So in a moment, I'm going to go over to my keyboard and go through a couple things that came up in the feedback on the knowledge check for week 5. I'll also talk a little bit through the solutions for the profiling assignment that I released the grades and comments on, as well as talking a little bit through some of the study materials that I've posted for the midterm exam. Okay, so let me go over to my keyboard, do all of that, and I'll see you on the other side. Okay, there were a couple things that came up in the feedback for Knowledge Check 5. First of all, in terms of the questions themselves, um, almost everyone got 100% on Knowledge Check 5, and I think only one student got one question incorrect. So I'm not going to go over the questions from Knowledge Check 5, but a couple questions came up in the feedback on the optional question 1. So the first had to do with the transformations that I covered last week. I talked about squaring variables versus logging variables. And the question was, although this makes your model fit better, does it hurt the interpretability of the model? Because again, part of the point of this week, where we're talking about inferential modeling, is we build these traditional statistics models to be able to look at the coefficients and say, this variable relates to that variable by this much, right? And so if you're squaring a variable or you're logging a variable, does that make that interpretation a little bit more difficult? So it does. There's a little bit of work you need to do if you want to interpret the coefficients. I'm going to quickly walk you through it. I'm not expecting you to know this. I'm not going to test you on this. But in case you're interested, let me just kind of walk through a couple examples. So first of all, let me load in our data set. This is the '06 stock data set we used last week. I'm going to be using NumPy, so let me go ahead and load that in. Okay, and I'm actually going to use a visualization package called Plot9, which you have not used yet. We're going to look at this later in the semester, but it's just a more flexible way that I can show you these scatter plots. So I'm going to use this because it's a little bit easier. So first of all, let me show you a scatter plot. This is comparing quantity to cost of goods sold. Okay, and if we do the scatter matrix, which is something I introduced this week in inferential modeling, you can see if we look at the revenue, what was it? I think it was quantity, COGS versus quantity. There's this curved relationship, and we can clearly see that quantity is heavily skewed. COGS is pretty symmetric, but quantity is heavily skewed, okay? So remember from last week, feature engineering, one of the things that I talked about is if you've got a skewed distribution that has no zeros or negatives, then the appropriate transformation would be to use a logarithmic transformation, okay? So let me just first show you the scatter plot up close. So this is quantity versus COGS. It's clearly a curved relationship. If I just simply throw this into a model, so this is using code from this week, I'm predicting quantity based on cost of goods sold. And if I simply run that model, I do get a statistically significant relationship between the two. This is suggesting that as COGS increases by 1 unit, my quantity increases on average by 0.28 units, okay? But the problem with this is assuming a linear relationship. The blue line that I drew here is actually the regression line from this equation, okay? Now, you can see that that regression line obviously is not doing a good job of describing the relationship. And so, as I said, a better way to do this is to log the skewed variable. So let me just do that directly in the scatter plot. So I'm going to basically transform this into a logged quantity and show you what this looks like. And you can see that all of a sudden it took away that skew. It makes this much more linear. So the point is now if I use logging here, so within my formula I can log this, log quantity, okay? And one thing I didn't point out, the previous model had an R squared of, I think, 0.825. That R squared went way up. It's now 0.993. So it's a much stronger model. Again, statistically significant. Now I've got a coefficient 0.01. And this gets to the question the person had in the knowledge check, which is how do I interpret this number, right? Because this is no longer like the data's been transformed, right? And so here's how you interpret the coefficient if you log your y variable. So in effect, what I've created here is what's called a log linear model. A log linear, I've logged the y, I've kept x linear. When you have a log linear model, basically what you do is you interpret this as a percentage increase. So in other words, for a 1 unit increase in COGS, my quantity is predicted to increase by 1% on average. So it turns this into a percentage increase, and it's 1%. So you would move the decimal over 2 spots, okay? So that's how you would interpret something that you've logged, is you interpret this as a percentage increase instead of a unit increase, okay? So it's a little bit different, but actually it's pretty straightforward, okay? You just have to remember that this is now a percentage increase instead of a unit increase in terms of quantity, okay? Anytime you log a variable in the model, you then interpret that variable as a percent increase or decrease rather than a unit increase or decrease. Now, how about the squared variable? So let me take a look, show you temperature versus revenue. So I'm predicting revenue based on temperature. We can see this curved relationship, this upside down U shape, okay? And again, I could simply run the model, and you'll see that when I run this model, actually, let me first run the model like this. Let me just run the model where I've not squared anything. You see you have a miserable r squared. You've got a p-value that's like way over 0.05, suggesting there's statistically no relationship. And you can see that's the regression line. And sure enough, that regression line is not describing this relationship at all, okay? So last week we talked about when you've got a U or an upside down U shape, one solution for this is to square the variable. So let me show you. If I square revenue, okay, if I square, I'm sorry, not revenue. I want to square temperature. And the reason I'm squaring temperature is if I look at the distribution for temperature, you can see it's got a very strange distribution. Whereas if I look at the distribution of revenue, again, that's pretty normal. So the issue is the temperature variable, okay? So if I square temperature, remember in Python, star 2, that means raised to the power of 2. You can see it, once again, it transforms temperature to make this much more linear. Okay, and again, I can do that in here. Now, one little trick is if you're squaring, you're actually creating a quadratic curve. And a quadratic curve is actually y equals x plus x squared. So actually, I would keep x in here, but I'd add on temperature asterisk asterisk 2. Okay, and by the way, if you're doing math in your OLS equation, you can use this I function, which isolates this so that it does math. If you don't do that, then it interprets this a little bit differently. So let me go ahead and run this, and you can see all of a sudden my r squared went from 0 up to 0.98, and you can see the squared term highly significant, okay? Now the linear term is not significant. That's to be expected because these two things are highly correlated with each other. But basically, when you square something, you treat this as a package because really the formula for a curve is x plus x squared. So I'd have to include both of these, okay? But it goes back to this question that someone asked on the knowledge check. Okay, great, this now fits the model better, right? It fits the model better. But if I'm trying to interpret these numbers, how do I do that? It turns out with a quadratic relationship, it's not as straightforward as a logged relationship. A logged relationship, I simply can interpret this as a percent increase. It's very straightforward. When you square a variable and you create this quadratic curve, unfortunately, it doesn't have the same interpretation. But you can make use of calculus, okay? And again, I'm not going to test you on this, but basically I can get the partial derivative of this curve to figure out where the maximum or minimum point is, okay? And the way that I would do this is I take the coefficient, I take the negative coefficient of my linear term, and I divide by 2 times the coefficient on my squared term, okay? So in other words, I'd take negative this, which is actually positive, so 0.0008 divided by 2 times the coefficient on my squared term, which is negative 0.9792. Okay, I get negative 0.0004. What is that? That's the inflection point. Let me draw this again as it was originally drawn. Okay, I've got this curve. The inflection point is, where does this switch from negative to positive, or positive to negative? On this side, it's a positive relationship. On this side, it's a negative relationship. And this partial derivative, where I basically got this from calculus, is this is telling me that the inflection point is at negative 0.0004. So like right around here, right on the negative sign of 0, that's the inflection point of this curve. So the way I could talk about this is, you know, as temperature increases, the revenue also increases up to a average deviation of temperature of negative 0.004, after which, as temperature increases, the revenue actually starts to decrease. Okay, so I could actually kind of use that inflection point to describe the relationship, and it tells me where it switches from positive to negative. Okay, so that's how that's potentially useful, but it is correct to say that you have to do more work to interpret these numbers, okay? But the point is, if I don't do that transformation, if I just simply do temperature, you can see it's doing a horrible job, right? It's not explaining it at all. So I can't even model this with a linear regression if I don't transform that in some way. Okay, so that's why transformations are very useful. Okay. Another question came up with a difference in the video versus the worksheet for feature engineering. Okay, so if I look here at feature engineering, let me come down to like one point that let's see. Let me find the code here. I think it was when we were turning something into a missing value. Okay, and right here, np.nan. So in the solution file, it's from NumPy, and it's lowercase nan. In the video, it's actually uppercase n, lowercase a, uppercase n. I just want to point out, I know it's awkward. They made this change in the past year after I've recorded the videos. So I did try to help you out a little bit. If I come over here and take a look at the Canvas page, I will just point out, I do have a note here. Okay, so I'm sorry if you didn't see that when you came to watch this video, but I did put a note here that this thing changed. It used to be this, it's now this. So in the video it's this, but now it's this. So going forward, when you're using this NaN value from NumPy, it's lowercase nan. Okay. Similarly down here, I think the very last example that I walked through in this file was using the select command. And I think initially in the video, I had default. I don't think I even had default. And what that did was it created a 0 value. They changed this function, and now it doesn't do that. If I run this without having default, I get an error message. So now if you've got any NAs, you have to put in default equals and then call it whatever you want. Here I'm calling it unknown. And that's how that code works. So that is also a little bit different from what was on the videos because the code changed. NumPy updated a little bit in like the last year and a half. Okay. So I just wanted to point that out. Someone had mentioned also on the knowledge check feedback that they just felt like there's a lot to commit to memory. And what I would just say is I'm not expecting you to commit any of this to memory. So on the exam, which I'll talk about in a moment, but on the exam, which is in a couple weeks, you have access to all of your Jupyter files. You're going to be using Jupyter Hub. It's not lockdown browser. You'll have access to all of these files. So I highly recommend that you organize this. In fact, I recommend open up an untitled worksheet and then go worksheet by worksheet and pull out really important code, right? So if I come over here, you know, maybe I want to have round, okay? I want to remember, oops, didn't mean to delete that. I want to remember how round works, okay? So then I come over here, I paste that there. And you just kind of keep pasting stuff from the worksheets. And what that will do is you can then access this during the exam so that you don't get into a situation where you want to look at the code from class, but you can't remember what week it was, right? Was that week 3? Was that week 4? If you put everything on a single document and organize your code and maybe write some notes, you know, this is from week 1, right? And just kind of put some notes in there, then you can use this during the exam. So again, I'm not expecting necessarily, particularly for the more complicated code, I'm not expecting you're going to commit stuff to memory. Okay. Now, throughout the semester, there's certain code that we're using over and over and over again. The read CSV function from Pandas, we're going to use that. I mean, we've been using that every week. We're going to continue to use that every week. My assumption is by the time you get to the end of the semester, you've memorized how that works, or df.describe or df.isNA.sum. There's certain code that we are using over and over and over again. So you become more adept at using that code. But yeah, on the exam, you have access to all of your documents. Okay. Speaking of the exam, I wanted to point out that I have posted review materials. Okay, so first of all, the exam, if you look down here at the schedule, the exam is during the week of 3/9. So that's the week after spring break. The exam will be posted on 3/9 and it will be due the following Monday on 3/16. So you have a full week to work on the midterm exam. Okay, it's again open computer, open notes. It is timed. It'll be an hour and a half in Canvas. And you can't pause it. So you just need to make sure at some point during that week, have an hour and a half available that you can take this exam. If you click on this midterm exam link, it'll bring you to a review page. Here are links to all of the managerial topic slide decks. And obviously, all of your worksheets are in Jupyter Hub. But I have posted a bank of knowledge check questions for knowledge checks 1 through 6 so that you can practice those knowledge checks again without messing up your grades. And then I've also posted in Jupyter Hub. So let me show this to you over here. In Jupyter Hub, notice that I've posted 2 files. So I've posted a set of midterm practice problems. So you can practice with a data set. Okay. Notice there's a ton of questions here. This is not meant to represent the length of the midterm. This is way more questions than I would ever ask on the midterm. I'm just giving you lots of practice. And then I've also posted the solution file for all of those questions. Okay. So that's currently in your Jupyter Hub. And I recommend you take a look at that to practice for the midterm. Okay. The last thing I want to point out, I did post the grades and comments from the first assignment on profiling. I think it was out of 24 points. The average grade was a 21.4 out of 24 points. So pretty good job there. Let me just quickly show you. If you go back to the assignment at the bottom, I've got a link to the solution file. And let me just quickly talk about some of these solutions. And I guess I have it locked, so I will make sure to unlock this prior to this video going out. Okay, but let me kind of walk you through some of these solutions. So question 1 was pretty okay. Question 2, here you had to get the data types, and I asked, are they all being read in correctly? And the one variable that's not being read in correctly is date. It's being read as a categorical variable. We probably should treat that as a date time variable. Okay, missing values, almost everyone got that right. The summary stats for numeric variables, almost everyone got this right. You just had to use the describe command. A couple of you used value counts. That's incorrect. You only use value counts for a categorical variable. Here I wanted for the numeric variables. df.describe does it all for you. Okay. Question 5 was asking you to talk about the distribution of rented bike count. Notice I said that I wanted you to give me a measure of center and spread. So if you lost points, it's probably because you didn't explicitly give me numbers, right? So the mean is 706.15. The median is 503. The standard deviation is 648.1. The IQR is 874. You had to give those numbers, at least one of each pair, okay? And the reason I'm a stickler for this is because as an analyst, it's your job to communicate about your data to the reader. You shouldn't assume the reader can come up here and interpret this stuff. It's your job to give the information directly, okay? And so I really want to make sure, and I tried to help you. I said, give a measure of center and spread. So I was trying to sort of be explicit here in terms of what I was expecting. Also, there's likely a skew, given that the mean is higher than the median. There's likely a rightward skew, okay? Question 6 was, what issues do you have with rainfall? The biggest issue that I wanted to make sure you pointed out is there's a lot of missing data for rainfall. Likely what's happening is if you look at the minimum value for rainfall, there are no zeros. And so I think what's happening here is if there's no rain, they just leave it blank, okay? That's the main thing I was looking for. You could have also talked about the fact that there's a huge anomaly. There's a huge outlier with the max. We go from 2.5 up to 35 millimeters. That's really huge. Okay. But the main thing I was looking for you to talk about was the missing values. Question 7, how many have a forecast of gold? The easiest way to do this is just use value counts. Okay. Some of you used some sort of logical condition dot sum, and you can do that. And I didn't mark that wrong because technically we've covered that code. But this is the way to do this more directly, is just use value counts. Same thing, question 8, I was looking for proportion. Again, some of you did a lot of sort of machinations to get to an answer using logical conditions and different sort of math, calculations. All you need to do is say normalize equals true with value counts, and it turns it into a proportion. Okay, 0.203 is what I was looking for there. Most of you got this one right. You had to put in margins equals true to get the row and column totals. So if you left that out, you only got partial credit. For this one, I wanted you to give me the proportions out of the total. So you had to put in normalize equals all. A couple of you put in normalize equals true, which technically works, but that's not the way we did it in class. So remember, on these assignments, I'm grading you based on the use of the code techniques that we use in class. So even if there's a correct way to get to something, if it's not the way that we did it in class, then you'll lose some points for that. Okay, that's also true on the midterm exam. So just be very careful on the midterm exam when it comes to the coding. I'm grading you based on the code that we covered in class. So even if you get to the correct answer with different code, you're going to lose points for that. Okay, so just be really careful with that. The visualizations, I think a histogram makes the most sense. Some of you did a box plot. That's fine. It's roughly symmetric. Scatter plot is kind of a positive relationship here. The stacked bar chart, I did want this to go up to 100%. The way to get that to work is you have to put in normalize equals index. A couple of you forgot that. Okay. And then finally, the side-by-side box plot, normal has the lowest median. Okay. And I think most of you got the graphs correct. If you lost points, a few of you used code that was way beyond the scope of class. So again, I'm grading you based on what we've done in class. So you have to cover that code. Okay. So, yeah, I think that's everything. If you have any questions on the assignment, just let me know. Okay, hopefully you found that helpful. So just a reminder for this week, we are in week 6. We're looking at inferential modeling. By the way, for the midterm exam, it's the content ends at this week. So the content for the midterm exam is from week 1 up through week 6. So next week, we're going to get into predictive modeling. That is not on the midterm. It ends with inferential modeling. The midterm itself is in a couple weeks, so it's the week after spring break. So just be aware of that. And in terms of things that are due this week, so this upcoming Monday, we're back to our regular knowledge check. So it's, I think, knowledge check 6, and it is discussion post 5, right? So back to knowledge checks and discussion posts. Yeah. Discussion 5, knowledge check 6. That's due this upcoming Monday. Okay. I'm grading the coding project profiling assignments, so I will get those back to you, as well as that connections assignment. I will get those back to you shortly. Okay. Hope you have a great weekend, and let me know if anything comes up. Thanks.